All right, this is a recording for 4.3. There's in the lesson an example where we need StatKey to help us get the p-value for a hypothesis test. So what we were doing in the lesson, here's example 5, where somebody was interested in whether there was a difference in the average amount of exercise time, male versus female. So you always start off with stating your null and alternative hypothesis. In this case, this right here is suggesting that they're the same averages for both groups. This one over here is suggesting that there is a difference. Maybe one group is less than or maybe greater than the other. So anytime we use the not equal to for the alternative, go ahead and note that this is going to be a two-tail test, which is going to help us get our correct p-value. So this is a two-tail test. Essentially, we're not sure necessarily, we're not favoring less than or greater than, we're essentially considering both. Maybe it's less or maybe it's greater. Now, after you have your hypothesis stated, then you need a statistic to help maybe give enough evidence to argue against this or in favor of the alternative. Now, the statistic is given here. They found from a sample of men 12.4 on average workout time, and then also 9.4 hours for the female. And so when you're doing a difference, this means that we are going to be doing some subtraction of these two numbers. Notice that if you do 12.4 for men minus 9.4 for women, that you're going to get a 3. And had they not given us that, we actually would also be able to obtain that from StatKey. But the next big thing that we're doing is using StatKey to give us the p-value or the likelihood for this having happened by random chance. And we're hoping this number is really small. When you go to StatKey, there's some different options for the different types of hypothesis tests. One of them, and which I'm going to use right now, is difference in means, like group A versus group B. So when you come in here, you're going to want to see your original sample over here. This is just something that's by default shows up. But over here, find the data set and variable that you need. This is exercise hours, male versus female. And when you click on this, you will see that they give us the statistic. In this case, it's really the difference of two averages from two samples that came out with a difference of 3. Now, we want to see if this is enough of a contradiction so that we can reject the null hypothesis, which over here, again, it always assumes that the null is true, that suppose maybe there's really no difference, that the two averages of exercises for these two, male and female, are about the same, or in other words, 0 difference. So down here, you'll see in the center, the idea that maybe there's no difference. And we're hoping that we have a statistic that is out here in the tail to contradict that idea. Now, when you're doing a hypothesis test, your alternative will tell you whether it's a left tail, if we're doing less than, or a right tail, if we're doing greater than. In this case, they were considering maybe it's one or the other, less than or greater. That's the two-tail. So when you click the two-tail, and then you generate your 1,000 samples, again, usually, and you don't have to have the two-tail on yet. You can run your 1,000 samples first. And then over here, click on your two-tail. And so when you open this up, it automatically defaults to the 95%, what we're usually using. But the thing is that you need to take your statistic and you need to place it here within the randomization distribution to see how likely this was to have happened by random chance. Now, everything in the 95% middle here is considered just happened by random chance. You won't likely see it happen on a routine basis in real life. But over here, this is not our statistic. We need to change this to that 3 that we got from the original sample. And when you put 3 in here, we're hoping that it's a contradiction or far enough away from the null, which is suggesting 0 difference. When you hit enter, right above is your p-value. Essentially 121 out of the 1,000 were this extreme or more extreme. However, we are doing a p-value for a two-tailed. So when we're doing a p-value for a two-tailed, we're considering the upper or the lower. And so we do need to take this number here and either add both of these, or in other words, take this one and multiply by 2 to get our accurate p-value for a two-tailed test. So when I go here, the p-value is going to be the 0.121. And if we were doing a right tail, we would be done. That'd be our p-value. But because we're doing a two tail, we need to take this and double it because we're essentially adding the samples from the right and the left. So you multiply this by 2, and this is going to give you your p-value for the two tail. So 2, and every time you do this, it's different. So I have to calculate this real quick. 242. And because this is such a big p-value, meaning it is greater than your level of significance, which is in this case 0.05, you would not be able to reject the null hypothesis. So you would say, do not reject. The other thing this would also mean is you don't have evidence to support the alternative, that there is a difference. Do not reject. And this is something that we went over in class. You need a small p-value to be able to reject the null. Again, smaller p-values means it was not something that was just a fluke. I'm going to skip this part here, but you would write out here something to the effect of there's not enough evidence to support that there's a difference in the average amount of exercise between male and female. Now, I want to give you one more example. This is not on the lecture handout. It's just one that I'm doing in addition, so that you can just see another example of like primarily how do you get a p-value from StatKey. So in this scenario, somebody was interested in finding evidence that the average price for homes in Canton are less than 265, specifically in thousands of dollars. So again, you start off with stating your null and alternative. In this case, somebody might be claiming or supposing that I really don't think there's an issue. I think it's always been $265,000 for homes here. But somebody comes along and says, well, I think there might be some evidence that it's less than 265. And again, this doesn't mean I wish this was $265 for a home, but this means 265,000, that it's less than that. And so in order to see if we have enough evidence to reject this one, we do need a statistic that's going to contradict it. And so up here, they don't tell us what the statistic is, but when you go to StatKey, you'll see over there where the value is for the original sample statistic. So I'm going to come back to put what is the statistic suggesting. And so when you go over to StatKey, what I'm doing differently this time is at the beginning of StatKey, I'm using this other option for a single mean. And I want the statistic that was done for this. And if you look through here, they have home price for Canton. And so they did a sample of 10 homes, and they got an average of 146.8, which does seem to be very much different and more specifically less than what's being supposed. So right here, someone is supposing that it's 265. Let's just assume that this is true for the moment, that it is really 265. So that's going to be centered here in the middle. And when you generate 1,000 possibilities of what could have happened, and this is a little bit skewed to the right, but that's okay. Now, you want to place your statistic down here in hopes that it's not here in the middle. You want it to be on either tail so that it contradicts the null. Now, over here, since we are doing a less than, remember we're checking to see this here is less than. So let me write this. This is a left tail test, meaning you're going to be looking or counting the dots that are on the left tail of the distribution. This is a left tail test. The other thing is they also give us what the statistic was. That was over here, the 146.8. And that does mean 146,000 or about $147,000 for the home. Now to get the p-value. So to get the p-value, you need to click the tail that you need. And over here to the left, I'm going to click the left tail. And down here, this is not going to automatically be your statistic. And you need to update that to the 146.8. So you can do 146.8. You're going to click OK. And then this is your p-value. So it is possible to get 0 as a p-value. Again, this is the smallest that you're going to be able to get. And so down here, the p-value is equal to 0.00, which means the likelihood of this having been a fluke is 0, right? There's very strong evidence that that we have a contradiction, that their price does seem to be a lot lesser than what somebody has been claiming or supposing. It doesn't really look like it's 265. There's evidence that it's actually something a lot less than that. The actual true average is less than this. Now, when you get to the generic conclusion, you are measuring it up against alpha. In this case, it's 0.05. And so because your p-value is less than this level of significance, this would give you the ability to reject the null hypothesis. So we reject H naught, which means we also have evidence to support our alternative. So what you would write down here is something like, we do have enough evidence to suggest that the average price for all homes in Canton is less than 265,000. In other words, this lost, this one, based on the sample statistic that was given. It was enough evidence to contradict the null. And again, we use the p-value as a measuring stick. As long as that's really small, it was not something that would be that happened by just random chance. Okay, so I'm going to stop there. And again, I hope these help you with your homework, but let me know if you run into questions.